So today we're looking at exponential growth and decay functions. And yesterday we looked at a COVID example, and in your assignment you looked at an earning money example of exponential growth, things that are going up exponentially. So as a reminder, 2 to the 5th, so that is 2 times 2 times 2 times 2 times 2, 5 times. So 2 to the 5th, we could say it's 32, and that expanded form is when we write it out. So let's take a look at a couple examples here. One cell divides into 2 every day. So we have a cell and it's splitting each time. So in a day it slowly splits into 2 every 2 days. So on day 1, the number of cells, you just have 1. And the next day, day 1, you still just have 1 cell. But on day 2, you would have 2 cells. On day 3, you would have 2 cells. On day 4, you would have 4 cells. Day 5, you'd have 4 cells. And then what is happening here? So let's see if we can graph this. And what we're going to do is we're going to switch this to every day so it fits on the graph a little bit better. So day 1, there's just 1 cell. Day 2, there's 2. And it's going to double every 2 days. So on day 1, there's just the 1 cell. Day 2, there's 2, 4, 8, 16, 32, and then we could say, well, the next one there's going to be 64. So it's this exponential growth. So we'd say it's 2 to the n power, because this is 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2. So our equation would be y equals 2 to the n. The second example that we're going to look at now is Miss Bajan found a new app that she liked to play. She only had time to play the app 2 minutes the day she downloaded the app, but then she made more time to play the app. She recorded the amount of time she played the game in the week below. So look at that. On the 4th day, she's playing it for 10 minutes a day, 15, and then 22 and 34 minutes. So how are we going to figure out how much she plays on the 8th day? So how do we figure out if there's some pattern here? It's definitely going up. So let's see. How do we get from 2 to 3? Well, what's 3 divided by 2 is 1.5. And let's see, here's what's 4.5 divided by 3. Well, that's 1.5. So 1.5 times more. So to get the 8th day, we'd multiply times 1.5. So can you come up with an equation? Well, we keep multiplying by 1.5. So we start with 2, and we keep multiplying by 1.5 to the n times. So this would be example of growth. So the next example here, you notice a colorful species of frogs inhabiting the nearby pond. The starting year, you count 160 frogs, and each year it goes down. So what's it going down by? Well, it's going down by half. So we could say that we're multiplying by half each time. So to get to the 6th year, times half, well, 2.5 frogs. Well, that's not realistic, but we'll just say that it's 2.5 for there. So what do we start with? We start with 160, and we're taking half of that for each day. So is this going up or down? Well, it's going down, so it's an example of decay. So how do we tell whether it's growth or decay? Well, let's see. This one, we're going to multiply by 3 each time. So this one here is going to be growth. What are we multiplying by each time? This is our factor, and that's less than 1, so it's going to be decay. And then this is our starting value, because we're going to start with 100. And decay times 0.5, so our decay rate equals 0.25. Our growth rate equals 3. So this next one, if I was to simplify this, this would be times 0.9 to the x. So times 0.9, so that has to be a decay. And it's decaying, our decay rate is by 0.9. And our starting value, what do we start with? We start with 12. So here we go. I'm going to do our starting value here. Well, it's just multiplying by 0.5, so we must start with 1. And it's going to be decay because it's 0.5, so it's decaying by half each time. Well, what do we start with? Here's the 3. 1 minus 0.25, so that's a decay because that's 0.75 we're multiplying by each time. Our starting value here is 11, and we're multiplying by 4 each time, so that's a growth, and our growth rate is 4. So in here, this is our starting value. And R is our rate. So if it's bigger than 1, and I'm going to say if the absolute value of R is greater than 1, it's growth. And if the absolute value of R is less than 1, it is going to be decay.